Okay, section 3.7, inverse functions. We're going to find the inverse of a function or relation, be able to tell if the two functions are inverses graphically and by using the composition of functions, which we just learned in 3.6. Okay, so inverse functions. When the domain of one set of ordered pairs is the range of the other. In other words, we're going to switch the x and the y, the input and the output, and so forth. So for each point AB of one relation, there is a point BA in the inverse. Example here, A and B are inverse of each other. So 1, 5 becomes 5, 1. 2, 6 becomes 6, 2, and 3, 7, 7, 3. Notice that the x and the y are switched. So over here in example 1, the inverse of 0, 3 would be 3, 0. 4, 2 would be 2, 4, and this would be negative 6, 5. Is the inverse a function? So we're looking at the second one. This is the inverse. We're looking to see, is this a function? Well, we have 3, 2, and negative 6. No repeats, so yes. 3, 2, negative 6. And our range of the inverse is 0, 4, and 5. So, find the inverse of the function. So, here are the steps right here. First, turn f of x into y. So, we're going to write y equals 2x minus 3. So, we're almost stepping backwards from what we learned in Algebra 2 back to Algebra 1. We're just going to make that y again. Now, we switch the x and the y. And now, we're going to solve for this new y right here. So the first thing we're going to do is add 3 to both sides. That gives me x plus 3 equals 2y. I'm going to divide by 2 the whole side. And that's going to give me y equals x plus 3 over 2, or 1/2 x plus 3/2. And now we're going to change y back into function notation using f negative 1. So we're going to say f negative 1, which means inverse of x, equals x plus 3 over 2, or like I said, you can do it this way, f negative 1 of x equals 1/2 x plus 3/2. Either one of those is appropriate. So, the graph of the inverse of a function is a reflection over the line y equals x. And remember, y equals x is that diagonal line right here. It goes up through 0 with a slope of 1. So this is your y equals x line. And if you think back to geometry, everything is reflected over that line. Notice here we have f of x equals 2x minus 5. The inverse of x is x plus 5 over 2. Here, f of x is a parabola, x squared plus 1. And here, notice, a little bit different, it's plus or minus the square root. That's what gives it the top shape and the bottom shape. Because if you remember, when we talk about square roots, we would only graph just this top part right here. Well, adding that minus gives you the bottom part. So find the inverse of f of x, then graph both. So first we write y equals negative 3/4 x plus 8. Now we switch them. X equals negative 3/4 x plus, y plus 8. I'm going to subtract 8 from both sides. I don't have a lot of room, so I'm not going to write out each step. X minus 8 equals negative 3/4 y. To get rid of negative 3/4, I'm going to multiply by negative 4/3. I want to do that on both sides. Ran myself out of room. So that's going to cancel, giving me y equals, now you got to be careful here, you got to distribute the negative 4 to both. So negative 4x plus 32 over 3. So notice again, you have the x is going to become negative, and you have 32 over 3. Okay? So when I rewrite this, we're going to be graphing it, I'm going to say negative 4/3 x plus 32 over 3. Which is also 10 2/3, which is just off the chart a little bit. So when I graph these two, x plus 8 is right here. And I have a negative 3/4 slope. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And remember, you can also just write it this way. This would be fine. Now, the first way I wrote it is in slope-intercept form, which means we need to have a slope of negative 4/3 and a y intercept of 10 2/3. Two reasons that's a pain. One, 10 2/3 is off the chart. Plus, with 2/3, you're estimating. So how about, let's go with the easier way of doing this, and let's write out the points on our original function here. We have 0, 8. We have 4, 5. And we have 8, 2. Well, what did we say happens in the inverse function? You just switch the x and the y, correct? So we're going to put 2, 8, 5, 4, and 8, 0. And then we're just going to connect those dots. And there's your inverse function. Sometimes slope-intercept will be easy to graph, and sometimes it's going to be difficult. So we just switch the x and the y, we have our graph. Now, is the inverse a function? Yes. Vertical line test would pass for either one of those. Okay, example 4, x squared minus 5. So first off, we write y equals x squared minus 5. We switch x and y, add 5 to both sides. We're trying to get rid of the y squared, so we take the square root of both sides. Which gives us y equals plus or minus, we have to do this to get both parts, x plus 5. So, plus or minus square root of x plus 5. Now remember, you can plug this into your calculator right here. X squared minus 5 it It's just a classic parabola, move down, and then use your points to your table to get some points. So it's going to be the same one, 0, -5, 1 and -1, -4, 2 and -2, -1, and so forth. It gives a pretty good idea of what it looks like. So again, let's write those points down. 0, -5. 1, -4. -1, -4. 2, -1. -2, -1. Those are just some of the points on our parabola. Now we're going to switch them. So -5, 0. 1, -4. Sorry, -4, 1. I'm gotta switch them. -4, 1, and -4, -1. -1, +2, and -1, -2. Oops. Go back. -4, -1, wrong spot. And then, there's your inverse function. Now, our original is a parabola, which passes the vertical line test. Our new one does not. But think about it. That's why this is so important. If we did not have that minus, we would not have the bottom half, and it would look like it was a function. But since we include that, it does not. Okay, so now we're doing a table. So we're going to pick some numbers for x. Remember, we want to pick numbers. We can't pick negatives, because there's no square root of a negative. So we're going to do 0, we're going to do 4, 9, 16, even though it's off the chart. So the square root of 0 is 0, times 2 is 0, -6. Square root of 4 is 2, times 2 is 4, -6 is -2. Square root of 9 is 3, times 2 is 6, -6 is 0. And square root of 16 is 4, times 2 is 8, -6 is 2. Okay? We still need to write it in inverse function, so let's go through the steps. Y equals 2 root x minus 6. Add 6 to both sides. Y plus 6 equals 2 root x. Oops. Grab the switch. X equals 2 root y minus 6. Move the 6 over. X plus 6 equals 2 root y. Divide by 2 equals root y. And we square both sides. Y equals 1/2 x plus 3 squared. So y equals, let's use our shortcut, 1/2 x times 1/2 x is 1/4 x squared. 3 times 1/2 x is 3/2 x. Double it. That's 6/2 x, which is 3x. Oh, sorry. Yeah, 3x plus 9. So the inverse of 2 radical x minus 6 is 1/4 x squared plus 3x plus 9. So parabola. So remember, to make life easier, first off we're going to put our points on 0, -6, 4, -2, 9, 0. So if we flip these, we get -6, 0, 4, sorry, after we get switching, -2, 4, 0, 9, and 2, 16. Let's see where that ends up. -6, 0, -2, 4, 0, 9, and so forth. But remember, this is a parabola. So we're missing the other part. So we can plug this in our calculator and see where, and look at the table. Otherwise, we can kind of figure out where the matching parts would be. -2, this point right here is 1, 2, 3, 4 spaces away from the vertex. So if we go 1, 2, 3, 4, that means it should be, remember, because this is the dividing line, it should have a matching point on the other side. And there's your parabola. Is the inverse a function? Yes, it is. Parabola is a function. And notice what it says here, because the range of f has to be greater than or equal to 0. The domain of the inverse must be restricted to greater than 0. Greater than or equal to 0. Now, we can verify if two functions are inverses of one another. You can check if two functions are inverses by finding both of their composition functions. So f of x and g of x are inverses only if f of g of x equals x and g of f of x equals x. Now, there are two ways to do this. We could follow the steps that we just did. Rewrite y equals 2x minus a, switch the position, solve. And if you did that, see if you end up with 1/2 x plus 4. And we could do the same thing with this and see if we end up with 2x minus 8. That is one way to do it. But we're also going to try plugging them into each other. So I'm going to write 2, I'm going to take x out and put 1/2 x plus 4 minus 8. Notice I've taken g of x and plugged it in here. Well, right here specifically. So I distribute the 2. Half of 2 is 1x plus 8 minus 8. 2 times 4 is 8. 8 minus 8 is 0. I end up with x. That's what I wanted. Now I go the other direction. 1/2, take out the x and put in 2x minus 8 plus 4. Half of 2x is x. Half of -8 is -4 plus 4 cancels x. So the answer is yes, they are inverses of one another. And last but not least, I'll plug 2. I'll put in the square root of x plus 1 over 2 squared minus 1. Well, when I square that, that goes away. So I end up with 2 times x plus 1 over 2 minus 1. The 2's cancel. X plus 1 minus 1. Looks good so far. And then I'm going to do the square root. I'm going to put 2x squared minus 1 plus 1 all over 2. Well, those cancel. So I have 2x squared over 2. 2's cancel. I have the square root of x squared, which is x. The answer is yes.